These are the instructions for the sound labs. So the very first lab we're going to do, show you how to do is get the data from, or the speed of sound. So for the speed of sound we need to open a particular file. So again, we open Logger Pro, we go under File Open, and we want to find Physics with Vernier, and we want to scroll down and find Speed of Sound, which is Lab 33. And so then it's going to open up this particular file, and you will have a cardboard tube that is closed on one end, open on the other, and you'll have the microphone just set in the edge of the open side. And then you're going to hit the collect button, and you're going to make a sound right by the opening of the tube. I've found that a snap works best. So if I hit the collect button, wait for the stop, and then hit a snap, what I get is this right here is the sound. This right here is the echo. This is another echo, and it kind of continues on and then starts to die out. So if I know the length of the tube, right, and sound's going to go down the tube and come back, and I know the time between the sound and the echo, I can find the speed of sound. So if you literally just click and drag from the start of the sound to the start of the echo, and then down here at the bottom you will see a change in time. That is the time it took to get from the top of this line to the top of this line, in other words, for the sound to the echo. So if you look at that delta t, that's what you record. And so you do 5 trials of this and find the average time, and then you also record then calculate the speed of sound. You're also going to calculate the speed of sound based on the temperature in the room, and we're going to go with a general assumption that we're at about 20 degrees Celsius. Alright, so then our next lab is going to be sort of basic sounds, and for that lab we need to open a different file. So if we go under File and select Open, we need to go and find, it says in here to use Lab 35, Mathematics and Music. We don't need to change or save any changes, and so we're going to see on the top screen just a regular sort of pressure graph, and on the bottom it's called an FFT. What it will show us on the bottom graph are the spikes for the frequencies. So for this one, you're going to be using a bunch of different things, but one of the items is a tuning fork. You want to make sure you don't hit it against a hard object, a soft object like the palm of your hand or the rubber stopper on a pencil that we have. But then you'll want to hold it perpendicular to the end of the microphone and then hit the collect button. So this one takes a little bit of coordination. And when you do that with this particular tuning fork, you're going to get a pattern up here. And then it asks you to count the patterns, or count how many cycles you have. So if I start here and I go, there's 1 cycle, there's 2 cycles, 3 cycles, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 13 cycles all the way to here. And again, if you then just look down, that delta t is the time it will take for those 12 cycles, which means then you can find the time for 1 cycle, which is known as the period. And if you know the period, you can find the frequency. The frequency from the FFT graph, you need to hit this x equals button, and then you click on, we need the x equals button for the bottom graph. You click on this spike, and it will tell you what the frequency is. And so then you can record that frequency. A couple other items you're going to use for this piece are you're going to be using what's called a tone dialer. And for the tone dialer, you're going to press and hold the buttons over the microphone. And I'm going to hit the collect button as I'm holding the button. And what you will see on the bottom here are 2 spikes. This is a low frequency and this is a high frequency. So you need to do the x equals on this graph to find the low frequency and find the high frequency. And you're going to do that for all of the buttons on your phone. And so 1 through 9, and then the star, the 0, and the pound key. For the mathematics of music and the beats, you're going to be using a keyboard. The keyboard needs to be in the flute mode for this particular lab to work. And so you'll plug it in, turn it on, and put it in the flute mode. You might need to turn the volume up a little bit, you can hear it there. Put the microphone by the speaker of the keyboard, and there are particular notes it wants you to find the frequency for. So you'll hold the note, hit the collect button, and then again you're going to be using this FFT graph here at the bottom and the x equals button to find the frequency for that particular note. And you do that for all the different notes. For the beat frequency, what you're going to do on the keyboard is find two white keys that are one apart, I believe. And so when you hear kind of a funky sound, and what you get is a new pattern formed up here. You can see the two frequencies that I was playing down here. For this new pattern, again, there's one of those patterns. I see two of those patterns. So if I see two of those patterns and I come down here and I look at the change in time. So if that's the time for two patterns, then I can find the time for one pattern. That's the period of the beat frequency. And I can find the frequency then from the period. The beat frequency really should be the difference in those two frequencies. So you can then go down here, find the actual two frequencies, and see how that compares. Then the last lab that you're going to do doesn't involve the computer. It involves the standing wave machine. The machine is a little bit different in each of the classes, but the idea is that you're going to create standing waves so that you see like 1 bump, 2 bumps, 3 bumps, 4 bumps, and 5 bumps. And then you're going to change the tension in the rope and see what happens to the frequency. And then you're going to do some calculations for the wavelength and for the wave velocity. Enjoy the labs.